Come on, YouTube, you can do it. There we go. Hey, YouTube. Good to have you back. We're decompiling Castlevania Symphony of the Night, of course. Or we could maybe work on this iPod Shuffle. Oh, too bright, too bright. How do I get that? There we go. Focus on my hand, and then you can see the iPod Shuffle. It's there. The battery on that is dead, which is a bummer. Kind of a fun little device. So what do we do when we decompile Castlevania Symphony of the Night? We take files that were from the original game. We disassemble them to get something that's somewhat readable. And then we try to reassemble them by writing C code that compiles back to the same thing that we disassembled, and hopefully assemble that back into the same thing that was on the disk. We've been working on Richter. There's a few things that I think would be fun to go over. If you go to soten.z.dev, you can learn more about the project. I'm a contributor. This is just something I like to do for fun. So soten.z.dev, I have a bunch of pending PRs. We'll see if any of them get picked up. 3. So I think I talked about the duplicates report already. We had, when we started using Ninja for build, that changed a lot of the dependencies and how different tools were invoked at build time, and the tools that were necessary to inject compiled symbols back into the splat config broke. And so this kind of rethinks how we did that whole process and does it in a way that doesn't disrupt the user's build environment, which is nice. Clean up build warnings. I like a clean build, and I'm actually guilty of another one that is currently plaguing the build. The issue that we had was font print had a different signature than was declared, and that's because this is a really strange function, and I didn't necessarily want to fix it this way, but to get something that both works with the PlayStation era compilers along with modern compilers, I found more difficult than I expected. The low here might not be the best choice, but this just needs to compile to PlayStation, and for portability purposes, we would not use this implementation, I believe. So I'm not too worried about it. Low is load word. It casts the variable as a word size, which is 32-bit on the PlayStation, and a pointer is 32-bit. So really, it doesn't change or manipulate any of that data at all. We don't have to worry about something breaking. The signature for this function is strange. So really, it takes whatever you want to pass it. There's 2 options for the first argument. The first is an ID, and that's what this check does here. It is trying to figure out whether or not you've passed a 32-bit number. The second option is passing in a string, or a char star as it's referred to in C. And then that's treated as a format string, like you'd see in printf or other things like that. Really bizarre how that works. I wanted to keep the long ID signature because that's what's in the documentation and that's what's in the PS1 SDK header. But I could not get that to compile in any reasonable way with modern GCC and Clang. So I capitulated and went back to the char star as the first argument. The other issue we had was a definition of clamp that we have multiple places. I just suppressed it, not a big deal. And then a third definition of clamp in our portable infrastructure, our portable stubs. Just got rid of that one. Pretty simple stuff. The second one, this is something that I've been meaning to look into for a while, and was not, basically until last night, didn't look into it at all. We have a bunch of tools. So when you get a game binary, and it's not just a game binary, any program binary could work the same way. Often you have graphics and sounds and other data, maybe textual data, that didn't originally come from a C file, but still gets compiled into the final binary. And you can reference that by a symbol. And depending on the framework that you're using to build those in, they may be accessible through different ways. Mac OS and like next step before that got away from that by using basically directories as application bundles, so you didn't have to pack everything into a single binary. But on Windows and embedded systems and stuff like that, it's pretty common to put those resources directly into the binaries. And so we have to extract those, and it's nice if they can be extracted and converted to something that's useful. So images, for example, are converted to PNGs, which if it was a thing in 1997, it was not a very widely known or supported format. I'm pretty sure by the late 90s PNG existed, because I was using it at least by 2000 or so. So it must have existed for a few years before that, but that's not a native format for the PlayStation. But we use it because you can have non-lossy compression, palettes, and other things like that that make dumping to PNG and then pulling that data back out easily. But the issue was, and we have other things like the blueprints, which tell you how the room is built and things like that. We use the same names regardless of which version of the game we were extracting. And sometimes that's fine. And so like we have these header graphics and they have the same symbol name, potentially between US, PSP EU, and HD version. But some of those assets are not the same. And when they're not the same, basically the last one to export wins. And the way that build systems work, or at least the ones we're using, we use Make and then Ninja, but a lot of the build systems work this way, is to look at the timestamp of the file that is the input. So we have this assets configuration as well as the splat configuration. Look at that, and then look at what they're going to produce. And if the stuff that's produced is newer than the asset configuration, don't do anything, because that's already been done. But when you have things writing to the same file, basically the last updated assets configuration was always the winner. And when you overwrite things that end up being different, have the same name on disk, but end up having different content, then you would end up in scenarios where an overlay would fail, even though if you cleaned and did it again, it would succeed. So I wanted to get away from that. How can we build HD, build US, build PSP EU, especially those three, and not have to worry about cleaning in between? And it's not perfect, but it's better. So basically namespacing all of those, and then in code, there's a few things to grab the namespace version instead of the other one. Dig Down Deep says the initial release of PNG was October 1996. So the Soten developers totally could have been on board with PNG, though I doubt that there was ever a native PNG library for the PlayStation. I could be wrong. Hey, Dizik, good to have you back. Hey, Daniel, good to have you as well. I learn by doing, and so a lot of this is just doing it for long enough to know. I'm nobody special. Just something I happen to be interested in, and decided to devote some time to. Ready to roll. All right, so we have We have those changes that are pending. Is that the biggest one? So then I was looking at this. So I added a build all target. We wouldn't have been able to do this before, which is pretty sweet. Build all target, and it goes through 4 versions of the game just sequentially. Boom, 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 boom. If you wanted to check a build before, or like you're working on the PlayStation version of the game, everything's compiling fine, you commit it, you push it to GitHub, and then create a PR, and then it fails in CI. And you're like, oh, I didn't check the HD version, I didn't check the PSP version, I didn't check the portable builds. This is meant to solve that problem. Before you check in, you can run this, and sequential, it'll go through them all. It takes a while, but it'll succeed as long as it builds everywhere. So that's nice. The one thing that's missing from this, and I looked into how feasible this would be, and I think it is reasonably feasible with a little more work, and I didn't want to conflate it. I'd rather get this in and then work on it, is building them all in parallel. And what's missing there is we do have assets that are shared and are the same. So they have the same name, but they might be coming from the PlayStation disk, they might be coming from the PSP disk, and they're all going to write assets, is all going to write them to the same place on disk. And from a file content perspective, that doesn't matter because it's the same. And if we didn't namespace it, we know that they're the same, and that's great because that means we can share that data, which is a good quality to have. We know it hasn't changed from one version of the game to the other. The issue is when, if you've ever dealt with file systems and concurrent processes accessing file systems and accessing data on file systems and how that works, you may or may not have run into the situation where you have a file writer, which is our assets tool. It opens the file and then starts writing data to that file. And then you have the reader, which may come in at any time during that write, regardless of whether the writer is done or not, or how much data has been written. The writer doesn't know when the file ends. It just knows how much data is the reader doesn't know when the file ends, just knows how much data. So it doesn't know that the writer might be halfway through its write, or just truncated the file, or anything like that. And that's the way assets works. It opens a file, starts writing data to it, and then closes the file. And so if you're coming from a different build, you see that that file is there already. It's on disk, and you need it. It's newer than your assets configuration, so you don't need to rebuild it. So you start reading from it, and it's a PNG or something like that, and it's only the headers there, and none of the data is there, and so you fail. So that sucks. Traditional race condition, just at the file system level. So the way that you fix that in file systems is to do atomic writes, and atomic in quotes. An atomic write is basically to not write to the file that you want your data to go into, but write into a temporary file. Typically that's in the same directory to make sure that it's in the same file system, on the same partition or hard drive or whatever. And then Unix is nice because you can actually unlink that file so it's not visible to anybody else. And then when you're done writing, you rename that file to where you want it to go. And file renames are atomic in Unix. So you know that if once you rename that file, everybody who saw it before is going to get the old data. Everybody who saw it after is going to get the new data. So kind of cool. So there's like 7 or 8 instances of that in assets that need to be resolved to do atomic writes. There's one more issue related to where we generate build ninja. Not terribly interesting. Basically, we overwrite the same build.ninja file for every build, regardless of the version, and so just namespacing that as well. So where were we? We were working on Richter somewhere in here. Here it is. So this is basically the main state machine for Richter. Cristiano, can you make an asset stop? So there's a couple things that make that difficult. So every version of the game gets its own Ninja build file. I don't know what Ninja calls them. So a build.ninja file for each version of the game. And that makes a lot of sense to keep that encapsulated at the game level and not try to intermix all versions of the game in one build.ninja file. But that means that so there's going to be a Ninja instance for every version of the game. And those build files don't have dependency nodes that overlap with each other, if that makes sense. Should that all be in one thing? I don't think so personally, but that's the way it is. On top of that, for the portable builds, we're not even using. So we used to have just Make as our build system, but the portable builds used CMake, and CMake can build to a Ninja file as well. I don't know. There's still a lot of complexity that would make that difficult. Yeah, I'll leave it at that. Even if they could, having atomic rights has a lot of other nice properties that avoid other race conditions. All right, so getting back to this function. So this is, we have at the top level the Richter entity function. That's called by the game engine to update all the entities. Basically, every frame they get a chance to decide what they're going to do, update their sprites, take whatever action, decide if they have to take damage or whatever. And so that's what we're doing here. The first thing is basically looking at all the timers, and all the timers have slightly different features. We actually have enums for each of these that we could go grab. They're all named after Alucard, but I think that they're the same purpose. So 0 is poison. Maybe not. Maybe they're not the same. It wouldn't make sense to reset poison every time. I'll leave it the way that it was. Let's look at 2. Hit effect. Hit effect may be correct. So yeah, I'm less convinced about that. This seems like 800 frames to do something. 800 frames is quite a while. Possibly hit effect 4 is unknown. And then 13 and 15. 13 is invincible. That may be correct. 4 invincibility frames, possibly. No, that can't be either, because well, I'm not sure. So we'll come back to that and potentially set breakpoints there and see what those are. All of that looked pretty reasonable. So there is some offsets here that are wrong. Not a huge deal. The way that the for loop is incrementing this, or no, this is the subtraction here, is a little strange as well. Somehow we're getting a double. No, I see the issue is sorry, thinking through. The S2 is our pointer, to where we are in the timer list that's getting pulled out. Some details there that are funny. I think I'm going to pull the PSP version eventually to resolve a bunch of that. 101 player draw. Player draw may be getting pulled out as a pointer because we don't see it here. The offsets here are strange though too. They're much higher than I would expect. And then when we get down into kind of the meat here at the bottom, we're loading this G entities field over and over when it's cached in most cases. And it's being cached into A0. And it's actually this Rick previous step. And so it's possible that that's actually what the argument here is, and we can try switching that. It's still getting put into A0. We basically need to track if A0 is getting overwritten here or not. We do have an easier way of doing this, though, which is grabbing the PSP version, which will tell us pretty explicitly. I would have to go through and replace all of those to know if it's GCC optimizing that or not. And I'd rather just grab the PlayStation version. There's some stuff down here around setting these arguments. Some spilling onto the stack, it looks like, for some of these registers. That's not happening in ours. 247. There's some stuff down here that we didn't get to yet that I think is probably worth looking at before we get too far. So here's this var S3. If you remember from yesterday, we have this var S3, which is saved reg var S3. If we go down and look at what the first assignment to that is, it's down here at Rick step case 1. And my guess is that this is going to be an OR equals. And so in all of the cases that are covered, are we always going to set var S3? And it looks likely so why do we need to make sure that we're setting var S3? Sorry, I'm going to get rid of this go-to. Because if we fall through and get down here, if we hadn't set var S3, then it would be initialized to whatever value is on the stack. And we don't know what value is on the stack, so it potentially has garbage data, and that could result in a bug. We don't know that yet. But it will be interesting to see, and we'll get that from the PlayStation. This var S3, oops, sorry, scrolling around too much. The var S3 ends up going to status, so I think just calling that status makes sense. And when we look at the PSP, it's going to have a different name anyway. Nothing that I've done has helped at all, which is not surprising. We see that this is update anim. I think we already know that these are... Oh, we don't know that that's an array. That should be an array. Get rid of... And I believe this is an array as well. Those types don't typically affect the PlayStation. So let's go through, see which of these are gone now. The hope usually is to get rid of as many of the temp V0s as possible. The temp V, any temp V is a good one to get rid of. Temp S isn't bad either, but in this case it looks like we're using it. And all those are gone now. I think what I'm going to try to do next, not next as in like the next step for this function, but the next step for what I want to try to tackle. This temp S3 looks like it should have been status. It doesn't make any sense that it would have been that other value. And that does help things quite a bit. I'm basing that based on what this flag is. Okay, a few more of these, and then I'll go grab the PSP version. I'm going to consolidate all these to the same var v0. It's unlikely that there is going to be a different variable there, and they're never used again. Somewhere along the way, I got rid of temp S0. Grab that. All right, so that's where we are. So how do we find the PSP version of the function? Typically, I look for a unique value. And oh, Calc 3. Very nice. I enjoyed my time in Calc. I think the plus and minus of Calc... So I enjoyed calculus quite a bit while I was doing it, and I enjoyed calculus for the sake of calculus. And then I finished all that, worked for a couple years, then went back to grad school, and was in a computer graphics class, and we're doing all this Calc for... transformations, light traveling, and I did not remember any of it. And between physics and between physics and computer graphics, those were the times when calculus was most applied in my life, and I ignored them. I never put them together, and I'm probably worse off for it. Oh yeah. I like differential equations too. So I'm a software guy. I knew I wanted to be software, but I did. We had to have a focus when I was doing my undergrad degree, and I chose electrical engineering. And boy, oh boy, that was hard. I'm glad that I did it. Other people chose like business, IT, things like that. Not me. The only thing I think might have been harder was like biomechanical engineering or something like that. But I made it. I survived. All right, so what am I doing? I need to find, this is one of the bigger functions. Let's go look at how big this is. I like differential equations, though. Could I do any now? Probably not. Could I do much calculus now? I can do integrals and derivatives. My oldest son is in, they call it Advanced Algebra 2 now, but it's, I don't know, we called it trig pre-calc when I was in high school. He does have a pre-calc class next year, but it's good stuff. It's hard, but you follow the rules and it works. Good luck on your test. I hope you're got a good score. So I'm looking for the function that we have. I need to look at non-matchings. Let's do that. I like putting type F in the command line. So if you're not familiar with Unix tools, I tend to use Unix tools. One, because they're ubiquitous. I can use them at a terminal. I can use them anywhere. There's a ton of documentation. There's like 50 years now of Unix documentation. And they're performant. And so that's the way I like to do things. Obviously, people do things different ways. Most people would use a graphical utility for things like this. I wouldn't know where to start, honestly, with something like that. So if this looks confusing, I apologize, but that's kind of the way I've always done it, and we'll continue to do it this way. Find is a utility for finding files, and it looks at the metadata of the files or the name of the file. It doesn't actually like search text in the file. So we give it a path where to look. This non-matchings is where all the functions that we haven't decompiled yet are going to go. I use the type F. So these are all predicates. So you're going to need to know predicate logic as well. Type F means look for files that are of a certain type, and that type being F file, so not directories, not devices, not other things like that. And the reason I like specifying type is it doesn't make a huge difference on modern computers. It's kind of an older optimization, but it looks, when you're going through a directory tree, you get metadata from the directory first, and you kind of get that for free. Give me a directory listing, and then you get all these dirents, they're called. And among those is a integer value, which is a bunch of flags, one of those being the type. And so doing type F as a predicate is a very cheap check. And so it skips directories, only looks at files. And then I do name after that. So name has to do string comparison. It's a little more expensive. And I want to look at... So this is the 5th biggest function. So I'm expecting the PSP version to be about the same. When we're looking for versions of a function between the different games compiled by different compilers with different settings, there's a few hints as to whether or not a function might be the same. One is the size. Relatively, is it about the same? PSP functions are going to be between 20 and 40% bigger because they're not optimized. It still checks out. It does. I mean, looking at dirents is cheap. So the size of the function. The other thing tend to look for is unique numbers, because the numbers will typically be in both of them. So I've like a palette overlay. So anything that looks like a complicated immediate number, or something that I think might have high entropy, I'll take those as well. So do we have a lot of things with 220 in them? I'm going to look in the US version first, and that'll give me a hint. And so I can kind of narrow down what my search criteria is. We have nothing. Oh, because it's not actually 220, it's 8220. So we have 5 functions. So 5 is too many. It might be a good starting point. So what other immediate values do we have? Anything that's based on the step, my guess is that there's going to be a lot of functions like that. The bigger the number, the better. This huge status flag may be good. And what I think is happening here, now I kind of see what's going on. I see what's going on here. I think the status flag is actually set out here. And then these are going to be or equals. We'll confirm that on the PSP though, before I spend too much time editing something and then being wrong. Okay, so anything else unique? Let's look for that big flag. We don't actually even see it. Why don't we see it anywhere? Because this gets split up into 2 parts. MIPS instructions are 32 bits. 5 of those bits is reserved for the opcode, of which there are 32. And the remaining bits then can be arguments to that opcode. When you're loading data into registers, you only get 16 bits of data that you can load at a time. And so if SPIM hasn't figured out that these are the same value, it may split them up. And this is actually a little surprising. I would have expected it to have showed up as a 16-bit value. Let's go over here and look at what ends up being. Yeah, it's there. Oh, it's not going to have the leading 0. That's why. So let's see. 1, 2, 3, 4. How many functions use that without the leading value? And again, it's about 5. So what if we combine those 2 things? Can we find a function that has that palette value? And the flag. Oh, there's one that does it a lot, and one that does it once. So I think that's pretty good. That narrows us down to 2 functions. So let's look at the size again. And we're working on this BC function, so let's look at the other function. It's much smaller. So now when I pull the PSP version, I have a pretty good search criteria, I think. And I should be able to find which one it is specifically based on size. So let's try that and see how wrong I am. I don't doubt that this will blow up in my face. We'll see though. That's part of the fun, isn't it? Making mistakes and then figuring out how to correct them. 2 functions. Let's what should we do? Please find I'm guessing it's the first one. Yeah, that's pretty big. It's actually not as much bigger as I expected it to be. And the other one is smaller. It's only about 10% bigger. I actually expected it to be much bigger. So most likely this is the same function. I would be shocked if it wasn't. So we'll start a new scratch in decomp.me. So it was commented earlier that not understanding much about the subject. What I do decompiling here. Ooh, yuck. There's some padding that shows up at the bottom of this. I'm going to look at this. That looks not nice. We did have a million jump tables as well, and the jump tables don't get... Excuse me. The jump tables don't get imported automatically, so we have to go find all those. So it's a little tougher. So at the end, we have this padding that falls over. I've not seen this before. So let's go find our jump tables. Don't paste the entire assembly. So the people who have set all this up, decomp.me, even individual game projects, getting started on any of these game projects is basically miracle work that people have figured out the right combination just to disassemble and then reassemble any of these projects, let alone all of the compiler settings, all of the various tools, both that had to be written as well as like sourced. I think this RO data with a dot. So I have to come through and find all these RO tables, or sorry, jump tables. On the PSP we get, or PlayStation, sorry, we get these for free. They get stuck into right next to the assembly file, which is nice. Make sure I have the right one. That's correct. Oh no, I have 58 already, or I have this one. I have this one. Okay, only 2. I think we had 3 on the PlayStation. So to get the jump tables in, they're in a different section or segment of, I guess, section of the binary, which is RO data that's separated from the game code itself. And so we have to specify that that this is supposed to go in the RO data section, and then we have to tell the assembler that this should go in the text section. And I usually copy this before I submit because it's a little error prone. And I want to make sure that I don't screw it up. Or if I do screw it up, I can get back to it. There's a couple things that could happen. If I screwed up the jump tables or didn't include them correctly, we might not get any disassembly or be able to do any disassembly. Sorry, not disassembly, decompilation from M2C at all, because M2C needs the jump table data to determine where each of these cases are going to go. And that's fine. We still have the assembly, and so we can work against that. We just won't know if we have all the labels correct. So I think there's some context data that's missing. Did I throw it? No, it's not. Not in the context. Oh, they're the wrong types. I see. So this is saying illegal operand. We're going to have to see. What I'll do temporarily is dereference the first element. I'm not convinced that that's what it's doing. It could. Yeah, maybe it is. We'll see. And the same thing here. It does look like it's a pointer comparison, though. And so let's bring that back. Let's go up and look at this one. So this could be a pointer instead. So it'd be a sine 16 pointer. And let's see what that would look like if we made it a sine 16 pointer. So this is another instance of compiler wrangling too. If it's not in the C spec, a compiler is able to do basically whatever it wants with it. And so something like this, where you're comparing the address of an array, which is the value of the label, that works fine in GCC, but not MetroWorks. Is there weird coding quirks like using lots of implicit declarations? Yes. And sometimes, so especially for, it doesn't affect GCC as much, but for MetroWorks, without optimizations turned on, it might not affect the optimization case. There are often times where having an explicit function declaration will not compile to the same thing. And so we know, or our best understanding is that function declarations were not necessarily included in a lot of places. And that, was it common for the time? No, but it was not as frowned upon. Was I a C programmer before doing decomp? I've done a lot of C, and it's one of my favorite languages. Look at our 68. Not good, not good. I do like C a lot. I think that that it's a better language than most people say. Is Rust and some of the modern languages, are those better? Maybe. I don't know. So I've done a lot of C. I did a bit of C++. C++, I eventually came to the conclusion that no one is smart enough to write C++ in a safe way. And I don't say that because I can't write C++ in a safe way. It's because while working at a FANG on very large projects that everybody has used, the smartest people that I can imagine could not write C++ in a safe way. And I found plenty of bugs that could have, they wouldn't have been business catastrophic, but they could have taken down services and things like that. So I have written C++ in the past. It's not a language. I'm like 15 years out of date, probably, maybe more on what's happening in C++. Probably 20 years out of date, honestly. So whatever C++ was doing around 2000 to 2005, that's what I remember. It was still, people still weren't sure if you should use the STL. I don't even know if it's called the STL anymore, Standard Template Library. Boost was kind of a thing, almost a thing. And Qt had basically a parallel implementation of the standard library. All right, so we're in PSP land. We are compiling, but we're not doing so hot. So what I'm going to do, and I like to do this, is go through M2C's implementation and see. So I hope that, Supreme Quetzal, I hope that answered your question. Yeah. It's just such a complicated language. All right, so what I'm going to do is kind of go through. We don't have nice symbols on the PSP side, so I'm going to do my best to try to identify what those are. The first thing I see is this var S3 getting set to 0, that we don't have. I say this a lot, but in case you're unfamiliar, the PlayStation 1 tooling was built around GCC and its tool suite. There's some things that Sony modified, some custom. I think the assembler was a custom assembler, but it's GCC. And then PSP, at least the tools that were used to build that game were Metroworks. So we have two different compilers. Two different compilers have very different ideas of how code should work, but that helps us because we can kind of learn the differences between the code generated by those two compilers and then try to find some common truth, least common denominator between them. Sometimes we'll see things like this var S3 being assigned to 0, but GCC, either this variable is not used and GCC decided that that's a dead store and they don't want to use it, or it is used and we see what it's used for, which is initializing the status. And so let's do that. It is possible as well that this was not in the original version of the game, that it was a modification for the PSP version, and so we have to kind of be aware of that too. Like, does it make sense on either version or not? And we don't know until we compare them, but we can at least get that in place. So I'm going to be flipping back and forth between how does this affect the decomp, how does it affect whatever. Our var S2, that's I, and our length of Richter timers is the 16 there. So that looks the same. M2C can't tell the difference between an explicit comparison against 0 and just a not, or truthiness. So I'm pretty sure that's the same on line 35. You have to understand that this is Richter, that this is the timer's offset. So we know those things. Our assignment there looks the same. Those look pretty good as well. And now we get into this. So the PSP in general is very good about assigning ephemeral variables to V registers and sometimes A registers, and keeping real variables in S registers. So if during this computation there's no S register involved before this assignment, it's most likely just done inline. So even this game timer, we might end up seeing that come back. No, yeah, so this var v0, that is... No, I need to look down here. Sorry, I need to look down a little further. There's this plus 200. And that looks like a real variable. Even though it's v0, it ends up being a real variable. I'm not sure why. I might have gotten spilled to the stack, but this is interesting, a bit interesting. And it starts out as temp v0. So we have it as temp s0 here. And then I did this plus float inline. What's actually happening is temp s is getting a 1/8 increment along the way. Sorry, just making sure that I'm... And so I think that these are still the same then. And what I don't know yet is if var v0 is real. My guess is that var v0 is not real. It's just happening inline. And so again, you have to kind of go back up where temp a0 is. It's getting assigned to v0. And here's where we have the plus 60. So I think, I'm not positive, but I think that this is just happening inline. And we can kind of watch. Let's go back over, look at the assembly. This gives us some hints too, some hints about the type. We have SEH instructions, which are used for going between 16-bit and 32-bit values on the PSP. Thank you, Cristiano. Appreciate it. Thank you, Dizik, as well. So I'm going through this, trying to determine which of these are variables and which are not. So this temp, it was called temp S0 on the PlayStation. It's temp v0 here, and the value, this temp v0 here, ends up being incremented by 200, which is the same as a float of 1/8. We call this float. That's a bad name. I didn't name it. I would not have used that name. Real is probably a better version, better name for it. In the docs, they call it a PlayStation. Oh, let me find the... What do they call it? A value in PlayStation format. They call it PlayStation format. That's the fixed 12, 20 bits of whole number, 12 bits of fraction. All right, so my guess then is temp S0 is a 16-bit value. Let's go down to 44-ish. What we need is a bunch of SEH instructions that seem to be missing. And we got those, just with that one change. So as as the transformations are happening, I don't know what game timer is offhand, if it's 32 or 16-bit. But typically the math operations are done in the 32-bit space, and then they need to be converted back. And so depending on where those conversions happen, you get more or less SEH instructions as you go through. All right, so player draw we see being referenced a lot, and the nice thing about the PSP is if we actually are accessing the global value, we'll see a global load, but we don't see that in this assembly. So it must be loaded at some point earlier, and we don't have a name for it, so we have to guess. And it will be a load that we don't really have a pair for. It almost seems like... Okay, so it's going into the S0 register, so we need to find the assignment to the S0 register, which is up here. So it looks like this player draw is getting assigned up here. And I want to see what type that is, so we need a pointer. And that's happening after the current entity. It looks like it's happening here. It's loaded into S0, yeah, the S0 register. So the S0 register will have the address, basically this address. It's loading the immediate value of this label. We don't know what that label is, and decomp.me doesn't know what the value of that label is. We can guess that it's actually this address, but that's just the convention that SPIM uses. And decomp.me doesn't infer any value or meaning from these labels. So it just knows that there's some load of an address, and not even an address, a constant. Not even a constant. The value of a global, and the value of that global is the address of that's place in the array. And so it's being called S0. Ours is being called S8. We'll resolve that eventually, but not yet. So now every time we have player draw 8 down here, we have to switch that to a pointer. And most of this, I'm hoping, will work itself out. We have a plus. Our add of 1,000 is in the wrong place, it looks like. That's the float one. So it looks like that should be, oh, I screwed up parentheses, possibly. Yep, that's all it was. And the last thing I want to see is, can we put this in line? I still think it is in line, but and that looks like it works as well. So the reason I thought it was in line is because of the V0 registers as opposed to being in an S register, which is what will happen if I put it in a variable. And so all these should be the same, then it's the same pattern over and over. We're going to add 1/8, and then we're going to do that assignment. So I think I can just replace all those. I don't really like how that ended up looking. Is the plus 60 a float? No, I don't think so. I think so. The sine function is going to take a float and return a float, and then the 64 is going to transform it into some space. So the values are going to range between, if we're talking integers and not floats, 0 to 4096, because it has to be 1. In radians, it's going to be 1.0 or lower. So 4096 divided by 64. So 4096 is our top end. Divided by 64 is what? 64. So this gives us a range of hex 60 to hex, I guess, possibly outside of the range of colors. It would loop over. Possibly. No, did I do that right? 4096. Oh, I didn't do it right. Sorry. I'm thinking incorrectly. So 64 is 40 in hex. So this would give us hex 60 to hex A0. AED? AED? Not 80, but so yeah, these basically it's taking an angle, trying to figure out. It's pretty common that this is done because it's going to give you a nice curve, right? Depending on where you are in that angle. All about the aesthetics. So we have registers that are wrong here, but that's fine. Nothing wrong. We're missing a label. I'm not sure why. Oh, because of all the reasons that we normally have. So, thank you, PSP. Always thanks to the PSP. This was one of the best things that I think was discovered so far on this project. What are some of the good things that would be worth discovering? We found a leak of the source code. Actually, that wouldn't be good because then we couldn't be doing this. Konami gave it to everybody on the desk. Maybe that's a better version of it. The fact that this is unoptimized, I think, is the greatest gift that Konami could have given us for this project. So I need to get enough of these cases in place to generate a jump table. We're not generating it yet. If we look at the switch, we're going to get a bunch of branches to certain places, and we need enough cases for it to spill over into a jump table. So I have 0 through 4. So I'm just going to keep adding them until I get there. And we should see these, the RO data pop in eventually. And this is something that compilers will yell at you about now in modern languages, often require it, which is having all of your every case covered. And it looks like somebody at Konami thought that that was important. We have a slightly different set, and that could be because the other switch is also not generating a jump table. We'll come back and see. So the other cases here, those look good as well. No complaints. So I think up to 89 here. I think that's all correct. And let's see whether the PlayStation is happy or not. Game timer is being loaded as the wrong value. So we have game timer as an unsigned 32. But because it's being stored in a 16-bit, let's change this to a unsigned. Nope. Because it's being stored in a 16-bit register, we're not doing a load word. Because it knows that that's going to get truncated anyway, so it just loads the bottom 16 bits. From like processor instruction, there's no real advantage to doing that. But it'll be a type that we have to resolve at some point. Looking back here, line 50. I just want to see if these instructions are correct. So yeah, this is loading it as a 32-bit value correctly, the load word instruction. And then it is doing the assignment into 16 bits. So we're gonna have to figure out how to trick GCC. We have ways to do that. What do you mean by that, Dizik? Dizik said, funny thing that PSP decomp has function symbol where it's missing. Oh, case 15. Let's see. Yeah, so let's look at that a little bit. So down here on line 88, let's go back to the PSP version, or PlayStation version, sorry. Is that what you mean? Isn't there a function symbol there? Or do you mean the other case 15? And then hex 15 or not? I'll keep going. I'll wait for your response and then get back to it. Look at the assembly on the PSP side. The fact, oh, yeah. So that is the way that our symbol matching works or doesn't work. And some of that symbol matching was probably may or may not have been broken in the same way that the duplicates report was broken, where symbols weren't getting, we call it hydration, the symbols that are in C weren't getting referenced correctly. Yeah, that is interesting. So we have a fuzzy duplicate finder, and the PSP one must have matched when the other one didn't. But that's, thank you for pointing that out. Appreciate it. I'm sorry that I missed your meaning. I'm going to namespace this because the disable after image is going to come from elsewhere. And it's gonna, the implementation probably is going to be different, either because it's referencing grick as opposed to gplayer, or the Richter entity. So the reason we namespace things is because when we do the portable builds, everything gets built together in a single binary, and that's kind of like how the Xbox 360 version of the game looks. And so if we don't have unique symbol names, we get collisions. And we tried a whole bunch of things to resolve this. I think the most elegant would have been to rename the symbols at build time dynamically. It's a little bit of work to do that, and possibly brittle, but kind of our own like name mangling. But this is just a simpler way to do it. Oops. Making everything. So now I have to go find the reference to this and update that as well. Oh, we have that one already. Fortunately, it's in 2 different files. Not terrible. And it looks like I probably have to go through and rename the doppelganger ones as well. One more reference to it here. So this is called in the outer entity Richter function, as well as inside this logic function, which is kind of funny too. Let's make sure that works. Love getting new symbols. Find reference. Oh, I screwed that up, didn't I? Sure did. All right. Back to the work. And might as well put the right symbol then in there. It'll be wrong in decomp.me, but we'll get the right one. Oh, was that? I did the wrong one. I did the wrong. All right, so like I said before, our RO data is in the wrong place. I'm not gonna worry about that too much yet. Sometimes RO data gets shifted. It's possible that all the cases that break are together and they're shoved to the end. There's a bunch of different reasons that these offsets could be wrong. I'm not overly concerned at the moment. Let's go down to 92 and see what's going on there. I think we might be doing 2 reads here. So I think I'll pull this out and see what... either that or we're checking explicitly against 0. Yeah, it's explicit check against 0. So this is our other jump table. So we have to do the same thing here and include all 15 cases. Fortunately, we have most of those. Some of these are out of order. They may or may not legitimately be out of order. We should be able to tell that as well after I get this in place. So we got our jump table now. The jump tables are being created, it looks like, out of order. That actually could be my fault. I might have put them in out of order. So this possibly can't be trusted. So I already have a 13. We have our overlay. We have our assignment to color blend. So those are all in order. Then we have a call to this function, set invincibility frame. So we have a symbol here that matched 2. I'm gonna I'm not going to go through the whole thing, but I am going to go add that symbol. And I'll clean it up later. I didn't namespace these when I was doing Doppelganger, and now I have to go back and fix them all. So when I'm looking at this, usually I will check the offsets and see if they're the same. So decimal 64, there's a decimal 64 difference between the two. And so as long as that stays the same between all the offsets, I'm pretty confident that they're going to be the same. Case 1 and 2 need a break? Of course they do. Thank you. We have a move into a register on 110. That seems to be missing. Oh, yeah, so this is one of the areas that I didn't like. So we're going to cast this as a Sign 16 pointer. And we still aren't getting the right set of registers. So this is being temporarily loaded into A1, the address of this global, and then moved into A0 before the jump. A1 and A0 are arguments. Oh, does set animation take 2 arguments? Let's look. That could be it. No, it only takes 1 argument. So why would this load into A1 first and then move to A0? That's not obvious to me. The comparison here looks correct. So I'm going to leave that the way that it was. All right, so now we have a load of entities that I think, are we getting down to this big mess down here? Not quite, not quite. So what I want to see every time we load entities, are we loading the same offset? And I'll do the low here. If we're not, then there wasn't an entity read there. So this condition at the top looks fine. This actually looks like it is checking the step, possibly doing this assignment. Function is called in several different ways, and it's possible that the argument is stored in a variable. I'm going to look at the decomp and see if M2C came to that same conclusion. It didn't. But we have a new name as well. Set step, I can't remember if that has 1 or 2 arguments. I'm going to look at that as well, and we'll add the symbol for that? Yeah, just one argument. So M2C is getting confused. It didn't see that this, or didn't, what's the right word, or how to say this? M2C didn't care that this 11 was getting set way before any of this other stuff was happening. Up here. And there another 11. Yeah. So somewhere up here is 17, sorry, value 17, a hex 11. So I think actually some of this may be repeated. Okay, so my current theory, and we'll have to go back and check, is that we're checking for not 70 at the top. And if that happens, then we're going to go way down to not that far. We're going to go way down here, so that looks mostly correct. But then if we fall through, now we are checking in again. My thought was that we would continually be checking against 11, and that happens, but that doesn't look like it's the case. All right. So let's look at this. It is compared against 11 again. All right, so let's do that. Sometimes there's a lot of duplicative logic, and so at this point, GCC knows that this statement can't be false because it would never have been able to get here if it was false, and so it just removes it and doesn't run it. Since step isn't marked as volatile, it doesn't have to do the read again. Or at least it assumes that it doesn't have to do the read again. And the only other thing here is the invincibility frames load. And that's just going to that. So that it looks like PSP. So this is a PSP exclusive, but it has this time attack controller call. And so we do have to wrap that in a PSP guard. And oh, maybe the step variable is not getting set here. Yeah. It looks like this 6A4 should be a unsigned 16. There is another global here, so there should be an assignment here for step S. That's not happening into some global. Let me go back to the PSP and see what that looks like. sorry, the PlayStation. We're not there yet. Yeah, so this may also be something that isn't happening on some PSP exclusive logic. So we're loading the step here into A1. Ours right now is V0. And it looks like that's what's getting assigned to... No, what's happening here? Loading into A1, then ORing it with... So I just was reading this wrong. No, not quite. This is not entities at all. Oh, it could be. It could be entities. But maybe not step S. Some 32-bit value. This isn't quite right, but I'm going to come back to it later. I'm not sure what that offset is. It looks wrong. Yes, the typing is off. So I'll come back to that in a bit, but there's some types there that are wrong and something else funny going on here. And that's why the masking is there. So there's unsigned 16 types that are being manipulated, and that can cause some issues as well. But we'll dig into that later. The register issues here, I'm not going to worry about either. As other register issues get resolved, those should work themselves out as well. A 153. This is interesting. So hit flags is going to be unsigned. So GCC generated this as a not equal to 0 condition. That 16A8, I thought that I went through all of these and found all the ones that were part of Richter. D160. A4 is just after Richter. So unknown 70 is 10 bytes away from the end of Richter, and this is so Richter's going to end at 98. 98 is going to come on, a line. There we go. Richter is going to be 98 or the next variable after Richter will start at 98. So this is another 20 bytes away. I think that's what I'm gonna go with for now. All right, now we get into, are we down here? No, we're not quite down there yet. Richter step, function, otherwise function. So these otherwise functions are not ever being called. It's possible that some of these branches are wrong, and so based on that, these would have been the otherwise functions. So we'll figure that out as well a little later. Where's this? Oh, so some values getting S5 is getting spilled to the stack. So we're missing some variables to cause the register overflow onto the stack. And then this is where I was hoping to get. So we don't generate a jump table here. Again, even though our switch is pretty big, we don't generate the jump table. Let's see if these are going approximately to the right place. Oh, there are no args to this function. That's what is causing all of this noise, and it was happening on the PlayStation. Well, how do I know there's no args? Because nothing is being loaded into register A0 or A1 or anything like that. So all of these, this is actually going to be super helpful. And these are all different functions. So these are all the implementation of what Richter is doing at these different steps. And so we need to figure out what the steps are before we can do that. Here is, so we're going to need a signature here. Or, yeah, I think we need a signature, SP10. So we're getting masked. Step and step S are being masked, but what we need is them, no, that's fine. We need them promoted to 32, but let's try making them signed. Yep, that was all that it was. Get them signed. These other registers, what we have is S6 and S7. Those are getting spilled to the stack as well. When I say they're getting spilled to the stack, what I mean is we've run out of space in the registers that we have for variables or the ephemeral registers. And we need to use the stack instead. And that becomes a more expensive operation then. We can't just look at what's in the register. We have to load the value from memory, write it back to memory. So that's what the difference here is. When the right variables get put into place, that will get resolved. There is a move here. So 200, it looks like the return value is being assigned to S0. So let's figure out what S0 is, if it's being used anywhere else. S0 is player draw. It's possible that S0 is being used there for other reasons. It seems like though that is being, return value is being used. Actually, there's two possibilities here. One of those is that we know the function signature, and the function signature is returning void or an int. I don't know which one. No, it wouldn't be int because that's the default. Not sure what's going on there. Oh, terminal. Thank you. Basically getting rid of the arguments for all these functions. Dizek says, is it possible to find other overlays, find out what these might be in other overlays? Yeah, so I do think the doppelganger overlays are probably very similar, and we've already grabbed a bunch of symbols from there. And then the Richter overlay is going to be very similar as well. My guess, the doppelganger steps were offset by 1 from the Alucard steps. And so let's do that quickly. See if the Richter steps are documented. Yes. So good call. Let's find. Let's try this. Kill me. So my guess is that this follows pretty closely. And just like Doppelganger, these are one off from Richter. So yeah, I do think that this is probably the same. And so that gives us a ton of information. I'll show Doppelganger. Here's my steps. They're named slightly different. I don't know if these were renamed, the Rick steps, since I've done this or not. But they mostly follow the same order as well. And so, yeah, that seems to be the case. And then I'm guessing that the high ones are unique because we go up to 32. And my guess is we have 40, 50, 60, 70. Those are likely unique to Doppelganger. So I'll pull those in a bit as well. Probably tomorrow. But yeah, that does give us a really good idea of what each of these functions is, and then we can name all those, and that's a ton of data. Let's see where we are. Register issues. I think we have the same thing here where there might be missing cases. So we're missing a case 9. No, we have case 9. Which case are we missing? These look like they are reversed. We don't have case 70. So for this switch, what I think happened is that there's too many cases. So we have to, we can't have a jump table because there's 60, what? X70 is going to be Over 64. Right? When hex numbers get too big, I freeze. Yeah, 112. So they're not going to generate a jump table that big. My time is up. That's all the time I have for today. So we made a lot of progress. Oh, I'm so wrong, aren't I? I already do have a 70. It's way up here. I think it's out of order. That's what I'm going to go with. Oh, hey, Nate. Good to have you back. A new account every week. All right. I will see you all tomorrow. Adios. Thanks for joining. And if you want to know more about Symphony of the Night Decomp, go to soten.z.dev. Join us in Discord. Adios.